Hello everyone, welcome to GChem classes. So today we will discuss rotational spectroscopy, correct? So I am having many questions also, PYQs, interesting questions. So in this rotational spectroscopy, so which molecule will give rotational spectroscopy, okay? Which molecule is your microwave active, okay? So only microwave active molecule will show this rotational spectroscopy. So for first we have to know that which all molecules will give microwave spectroscopy. Suppose you have one molecule H2, okay. So in this rotation it won't be possible. Why it is not possible? Like normal rotational spectroscopy it won't give, but in Raman it will give, right? So that is something different concept, Raman. So in rotational, like microwave, this is not microwave active, right? This is microwave inactive. So which molecule will be microwave active? So the molecule which have permanent dipole, correct? The molecule which have permanent dipole, only those molecule will be your microwave active. Suppose you have HCl, okay. So how this polarity will be signed? Like the electron density going towards this chlorine side, correct? So this one will be your this one will have the permanent dipole, and based on that this will have your microwave active. And if it is microwave active, here we will find the rotational like rotational energy level. We can work with this type of molecule. So in rotational spectroscopy we will deal with the solid rotor, okay. We'll discuss with the solid rotor, and then we will discuss the isotopic effect, okay, isotopic effect, okay. And then we will see the energy level, okay, wave number, okay, with the per centimeter energy level, and then with joule we'll solve the energy level. We'll see the gap, energy gap between the different J level. What is the selection rule for this rotational spectroscopy? Everything we are going to see. And whatever concept I have brought here, that is fully depend on your PYQ, okay. Whatever PYQ they have asked, based on that I chosen these concepts, and that I am going to discuss it, and then I'll solve the problems also, okay. So let us start first for solid rotor, okay. So solid rotor we will have the example HCl, you can take example, but better we'll take one bigger mass, one smaller mass, okay. These two is connected with this bond, so this will be your bond length. What is the bond length? Bond length will be your R, okay. I'm not going to derive fully, because if derivation I will start, then it will take 2-3 classes, correct? So this will be R. Now for this type of molecule, this is M1, this is M2. For this type of molecule we have to find the central center mass, right? Center of mass. So this will be the center of mass. The bigger side the center of mass will shift, correct? So this point C we call it center of mass, correct? Now in this axis, okay, if you are taking this axis, in along with this axis it will rotate, right? Like this it will start rotating, correct? So from here to here the distance if we take, it will be R1, and from here to here if we take this distance, this will be your R2, and based on that we will just find out the reduced mass, okay. And then with reduced mass we'll find the inertia, moment of inertia. So what will be the moment of inertia here, okay? After the derivation you will get it, this mu R square. This R is the bond length, okay. So this type of question in this rotational spectroscopy, they might give you that find out the value of the bond length between these two, between the molecules, right? So this mu R square, I'll just explain this mu. Mu is your M1 M2 divided by M1 plus M2, okay. This will be your mu, and we call it reduced mass, and then this one is R square. So your moment of inertia will be based on this formula. Why we need this formula? To like for time being to solve our problem, right? Because we have examination on 12th February. So to solve in that examination we need this formula. Otherwise if in free time if you ask why we need this formula, I'll explain you, okay, 2-3 lecture I'll explain you why we need this formula, correct? So now going forward, we'll see the energy. So EJ, energy will be your, here it will be h square, okay, and then 8 pi square, and then your moment of inertia will be there, pi square, and then I, and then it will be j plus 1, and it will be in joule. Okay, whatever you are getting, that will be in joule. So this is energy, and now we know that to energy we have to convert it in per centimeter, wave number. Okay, so you have to find out the wave number and then the difference of the wave number, correct? Because your answer from like some of the questions in answer they won't ask you in joule, they will ask in per centimeter. So for per centimeter you have to convert it. So we know already that energy equal to H, then C, and this nu, right? C and nu bar. So from this we will get this nu bar. This is wave number, nothing but the wave number. Okay, wave number equal to, it will be E equal to Hc. Okay, this value you just put it here, right? This energy value, no, you just take this value and put it here. You will get the per centimeter. How to calculate in per centimeter? You will get that formula, correct? So that we will do it here. This is normal rigid rotor we are doing, correct? Our main focus is to solve problems. Like at present, our main focus is to solve problem, correct? Now in this, we'll put this energy. So wave number equal to energy. What is the energy? It is h square but 8 pi square I is moment of inertia, and then j plus 1, and then your hc. So it will be like divided by hc. So h and this square will get cancelled out, and you are getting the new formula, that is h but 8 pi square I c and j plus 1. And you know, we what we called for this particular value, this is called as b, right? B. This b, this constant value, that is equal to h but h upon 8 pi square I c. Okay, so directly we can write it equal to b j plus 1, correct? This is your wave number. Okay, whatever value you will get it from here, it will be per centimeter, correct? Now our main focus is to find out this b value, and then j plus 1, and then different energy level, like j value, j equal to 0, j equal to 1, j equal to 2, j equal to 3. Just we will find out this energy separation, and we'll calculate for each energy separation what will be the value for b, okay, and what will be the wave number. Everything we are going to calculate it. So I know you are waiting for the problems, PYQs. We will solve it. The rotational energy level, okay, rotational energy level for a diatomic, we call rigid rotor, rigid rotor. Okay, just we'll draw it here. This side it will be j value, okay, 0, 1, 2, 3, 4 only we will take it. There are many, we'll take till 4. Okay, so if it is 0, j equal to 0, then here it will be 0. Okay, and if it is 1, then here it will be 2b. Okay, how it is coming, we'll see. First we'll see the selection rule. Okay, what is the selection rule? Directly they will ask these questions for j value, rotational spectra, j value, what is the selection rule out of these 4, okay? So delta j equal to, it will be plus minus 1. So it means, what is the meaning of this selection rule? Means this energy level, it can jump from 0 to 1, okay? It can't jump from 0 to 2, or it can't jump from 0 to 3. Okay, it can only jump from 0 to 1 or 1 to 0, and again it can jump from 1 to 2 and 2 to 1. It can jump from 2 to 3 and 3 to 2. It can't jump from 2 to 4, correct? Or it can't jump from 1 to 3, because J, delta J, the selection rule is plus or minus 1. Okay, either 2 to 1 or 1 to 2 it will go. Okay, but it can't go 2 to 4 or 4 to 2 or 4 to 1. It can't possible. Okay, only one ladder it can go, not 2 or 3, correct? So this is the selection rule for J value. So now you just see it, this is 2B. What about, like, how this 2B has came? We have our this wave number, how we have to find? We have B and J plus 1, right? So just see, B into 1, J value is 1, and then 1 plus 1, it is 2. So how much it is coming? 2 into 1, 2, so 2B. Okay, this Vj, J, if it is 1, then you are getting this one. Suppose your J value is 2. For 2 you are counting B 2 plus 1. Okay, just calculate it, how much it is coming? 2 1 3, 3 into 2 it will be 6, so 6B. So when it is 2 it will be 6B. When it is 3, how much it is coming? We'll see how much it is coming. Okay, when your J value is 3, then it will be B into 3 plus 1. Okay, how much it is coming? 3 and 1 4, 4 into 3, how much it is? 12. So this is 12B. Okay, here it will be 12B, correct? And then next, your wave number, this 4. Okay, fourth one, this J value is, if J value is 4, how much it is coming? B into 4, 4 plus 1, how much it is coming? 4 1 5, 5 4 is 20. So 20B it is coming. Okay, likewise you calculate. Okay, they may ask you, you just find out for J value, J equal to 50, then you have to find J equal to 50, B into 50, 50 plus 1, so it will be 51, 51 into 50, how much it is coming? That much B value it will be, right? So now this is the rotational energy level for a diatomic rigid. Now we have to calculate the energy absorbed. Okay, these are the energy level, but how much energy it has absorbed, that we have to see. So this, in this, if 0 to 1 if it is going, okay, or 1 to 0 it is coming down, how much energy it has absorbed, or 0 to 1 if it is, sorry, 0 to 1 if it is getting going, then how much energy it has absorbed, or 1 to 0 if it is coming down, how much energy it emits. Okay, so likewise from 1 to 2 if it is going, how much energy it has absorbed, or 2 to 1 if it is coming down, how much energy it has emit. So these are the differences, and we'll see how to calculate these differences. We'll just calculate the delta J value. Okay, we'll see how we are calculating. We'll just simply will write delta J equal to J prime minus J double prime. Okay, we know that this J prime is your higher J value, and this J double prime will be your subsequent lower. Okay, subsequent lower. It is not like that J double prime is 0 and J prime is your fourth. It is not like that. Okay, J double prime will be your subsequent lower J value. Okay, now for this difference, if we want, we will have delta E, which one? This 0 to 1. Okay, so we can write it here, J prime to J prime to 0 to 1. How much it is coming? We have to write, it will be like your J prime minus J double prime. So J prime minus J double prime means 2B minus 0. Okay, it will be 2B. So this difference is 2B, correct? Likewise, del E, okay, what is that? 2 to 1 if it is going, or 1 to 2 if it is going, how much it will come? Your J prime value is 6B minus J double prime value is 2B. So how much it is coming? 4B. Okay, just write it down here, 4B. Likewise here also you can calculate 12 minus 6, it will be 6B, and 20 minus 12 it will be 8B. Okay, you got the value for the differences. Okay, so the different energy level how much energy they have absorbed, that value you have got it. Okay, 0 to 1, 1 to 2, 2 to 3, 3 to 4, those energy absorbed value you have got, and based on that we will just draw a spectrum. Okay, we are going to draw a spectrum based on this. Still we are discussing the rigid rotor, correct? We are still discussing rigid rotor. So this will be your spectrum, okay, and it is in per centimeter. Okay, so first will be your 0, then second will be your 2b, third will be your 4b. The differences I am just writing here. Okay, the differences I am writing. Then fourth will be your 4b, after that it will be 6b, and then next one will be 8b. Likewise it will go. Okay, now you just see the energy differences I have written here. The energy, like absorbed energy I have written, and based on absorbed energy I have drawn this spectrum, correct? Based on absorbed energy I have drawn this spectrum. Now the absorbed energy differences we have to see how much it is coming. For here to here it will be 2b, from here to here it will be 2b, from here to here it will be again 2b, from here to here it will be 2b. Likewise, if you are going till infinity, the differences will be always 2b only. Okay, so this value is constant. You are getting constant value, this 2b, correct? So the problem, when you will see the problem, that time you will come to know what is the meaning of this 2b. They will say that two consequent energy level differences are this many, like this much per centimeter. So now you calculate what will be the bond length of this particular molecule. Okay, so based on this you are going to calculate the bond length. Okay, in general we can say it. Okay, let me rub this one. In general we can say the J value, how we are going to find it out for any particular number. Suppose they are telling that you find out for 1000th level of J value. So in general we can say that we have J double prime is J and J prime will be J plus 1, because we know that J prime is a higher energy level and J double prime is a lower energy level. So this value we have. Okay, and now we just put this value in del this wave number frequency. Okay, how much it will come? Del this wave number at for J region, if you are calculating, how much it will come? It will be J plus 1 and nu bar J. Okay, just put the value for this value B, and this is J plus 1. So J plus 1, and then we have J plus 2. Okay, and then minus B, J, and then J plus 1. This formula we have taken initially, we have drawn. So we know that this formula already we know, right? We already seen this Vj equal to your B, J, J plus 1. Okay, so if it is for J, this you will get it. So Vj, see this Vj, this wave number and J, you are getting this one. If it is J plus 1, instead of J, okay, instead of J you put J plus 1, and then instead of J again you put J plus 1, and then plus 1 is already there here, right? So how much it is coming? J plus 1 and then J plus 2. So these two value only I have put in here, right? These two value only I have kept here. So now you have to solve this one. Okay, correct? So now which, like, we have to take some common values. So common value is J plus 1, here also J plus 1. So B, then J plus 1. Okay, this will be common, and then here this side it will be J plus 2 minus this J. Okay, minus this J. So minus and plus, it will get cancel it out, and then how much it is coming? This 2 will come here. So 2B J plus 1. This is your difference of two consecutive energy level. Okay, two consecutive energy level, you are getting this difference. Okay, so this formula is very much required for your problem solving. So whatever formula I am just drawing with this within this square, that will be important for you. Okay, just do practice of these formulas. Directly they may ask you these formulas and what will be the formula. Now we'll see for isotopic effect. This is normal rigid rotor we have done. For isotopic effect we will check it how that will working out. Okay, same like starting I have written, this will be your M1, but now it will be prime, and here it will be M2. Okay, likewise it will have here center of mass, from here to here distance is R. Okay, this is R1, this is R2, everything will be similar. Okay, only what is happening, the mass M1 I am changing to M1 prime. So and one more thing, this M1 prime is greater than your M1. Okay, here I'll write for the original one. Okay, this is M1 and this is M2, correct? So we know that this M1 prime is greater than M1, so this is a isotopic one. Okay, so this mass is heavier than this mass. Okay, now what will be the effect for your entire whatever we have drawn out for this rigid rotor? What will be the changes, where the changes will be there? So first of all, the reduced mass will get changed. This will be mu and this will be mu prime, correct? So in reduced mass, what will be the changes? It will be like, we know that reduced mass equal to M1 M2 divided by M1 plus M2. If it is prime, then here also prime, here also prime. For this, what will be the value? M1 M2 divided by M1 plus M2. So here one thing you see, this M1 and M2, if it is multiplying, here also M1 prime and M2 is multiplying, and we know that this value is more. So directly we can say this value will be more, right? Mu prime will be greater than mu. The reduced mass, this one will be greater than this one. So likewise, the moment of inertia will also get changed. This is the situation. What will happen? You just see mu prime, it will be less than 1. It will be less than, if you are just dividing mu prime, it will be less than 1, correct? So directly they can ask this type of question also. What will be the ratio of reduced mass, whether it will be lesser than 1 or it will be equal to 1 or it will be more than 1 or it will become 0. Okay, 4 options they can ask. So it will be like your normal reduced mass divided by your isotopic reduced mass, it will be lesser than 1. If this one is lesser than 1, so what will happen? Just see mu equal to, it will be B prime and then B. Okay, that also you can do it. Okay, because we know that what is the value of B? B is H divided by 8 pi square I C. Okay, and this I we will open it now because we very much require now mu R square for this B, and for B square what will be the value? Both the values I will write, like sorry, B prime we will write it H divided by 8 pi square mu prime R square. Now everything is constant, R is same, pi, 8, H, everything is same. So what is happening? See, for B prime, mu prime is in down. Okay, if this is more, then this value will be lesser, right? Here, if this value is less, this value will be more. So likewise you see, if this divided by this, it will become equal to B prime but a B. It means your B value is greater than B prime. B value is greater than B prime. Okay, so how we got this B is greater? Because see, here it is lesser reduced mass, here it is more reduced mass. Okay, so if it is more, it will be lesser. If it is lesser, it will be more. So from there we find out this one. So now the comparison energy level spectrum we will draw it. Okay, not energy, and first we will draw the energy level, energy J values, and then we will draw spectrum, and both the differences we'll see. In one PYQ they have asked this question. Okay, I know in one lecture it is very much difficult to make you understand, because without derivation this molecular spectroscopy is little bit difficult to grasping. Okay, so better you just do whatever I am just giving you concept, at least 2 to 3 times you watch it, you will get it. Okay, you will get to know. And if you are not getting, you directly ask me question. Okay, I'll just elaborate that particular point in a paper and I'll send you that image to you, right? So now the comparison we will do it. This side I'll write, this is M1 and this is M2, This is also rigid rotor, and here I'll write this is M1 prime, and here it will be M2, correct? So first the energy level we'll see it. Okay, from here I'll draw it. This will be J equal to 0, then J equal to 1, then J equal to 2, J equal to 3, J equal to 4. Correct? This energy level we have drawn it. Just assume it, this difference is lesser, this difference is more, this is again more, this is again more. Okay, just do that differences. Just I'll write it here. It will be 0, it will be 2B, it will be 6B, it will be 12B, it will be 20B. Correct? Now this side also I'll draw. For 0 and 0 it will be same. J value is 0. I'm not writing. This side it is already written. Okay, it's a 0. Okay. Here for 2B, okay, it will be little bit lesser than this 2B. 6B, again it will be little bit lesser than this 6B. 12B, again it will be lesser than this 12B. And 20B, it will be lesser than this 20B. Okay, what is happening? This is in same energy level. This will be little bit less. This one will be again less. See, the more the J value it is increasing, the differences is getting more. Okay, in 0 both will having same energy level, whether it's a isotopic one or normal one. But as you go the larger J value, the differences is more. See, here the differences is little bit, here the differences is more. Okay, this is down and this is up. This one is further lower energy level, this is upper energy level. This is again lower energy level, this is upper energy level. Okay, why this one is happening? Because your B value is getting changed. We know that we already having B is greater than B prime, right? So whatever value we are getting here, it will be 0, it will be 2B prime, it will be 6B prime, it will be 12B prime, this will be 20B prime. Okay, so always if it is B prime is lesser, obviously this value will be lesser, right? And all are in per centimeter, correct? So now this energy, whatever the energy difference is there, for that we will draw it the spectrum. Okay, we will just draw the spectrum and we'll see. Okay, and we'll start solving PYQs. So this difference, how to calculate this difference? Let's see, I'll draw it here for normal rigid rotor, and I'll draw it here for your isotopic rigid rotor. And in one spectrum only I can draw both the things, so easily we can compare it, correct? So this is a spectrum. Okay, this is the 0 value, this one is 2B. Okay, this value, this difference will be 2B, this will be 4B, this will be 6B, this will be 8B. Okay, those things I'll write it. 2B and then 4B, then your 2B, 4B, then it will be 6B, then this will be 8B. Okay, now this is for normal rigid rotor, correct? And we have prime. So see, before this one dash line will come. Or it just simply I'll do it what? This normal one, M1, M2 will make it this line, solid line, and for this M1 prime and M2 we will make it your dash line. Okay, so it will be 2B, this dash line is belongs to 2B prime, and then 4B, again see the difference here. Okay, 2B and 2B prime difference you see here, you difference again, you see the difference for 4B and 4B prime. Here you see the difference, 6B prime, here you see the difference, 8B prime. Okay, see the difference is less, then it is increasing, again it is increasing, and it has increased. Okay, likewise it is increasing. Okay, slowly it is increasing. One question is having, I'll just discuss it, is very nice graph they have asked in 2022 only they have asked. So now we will solve the PYQs. One by one I will take it. If any other concept is required during the solving PYQs, I'll solve it. Okay, don't worry about that. Okay, so we'll take one by one PYQs. So first we'll take it from 2022, question number 23. Correct, question number 23 from 2022. Okay, JAM 2022. 22, question number 23. Okay, before solving this PYQ, I am having one announcement. Okay, so IIT JAM 2024. Okay, IIT JAM 2024 English medium batch, we are starting from 13th Feb. Okay, already we have launched. You can directly go and see in store section. Okay, we have launched this. It is fully English medium batch. Okay, many concepts are there, like whatever your syllabus, all the concept it has covered, and then maximum number of example we are solving here. Okay, all the PYQs we have solved, then with different standard books. Okay, different standard textbook. Okay, we have solved, we have taken the problems from those exemplar book, and we have solved those problems. Every day we will have class. Okay, it is a live class. It will start from 13th February and it will continue till your IIT JAM examination. And one more thing, if you are enrolling now, you will get free this gift. Okay, that is IIT JAM test series for 2024. Okay, in that we have 31 test paper. Okay, full length 31 test paper we have. In that, part A, part B, part C. Okay, all the part has covered. Okay, and it will be like your examination, how you are appearing for JAM examination. Likewise it will have, okay, that window, everything you will get it, the scientific calculator, that how many questions you have solved, everything it will be written in that. So do join this batch for completely English medium batch and support us, because we are also working for you, right? So the same thing I also expect from you. So kindly join this and explore yourself. Okay, thank you. So now we'll start solving PYQ again. Okay, so 2022 question number 23rd. Okay, what this question says, now you can see the question in screen. It is the spacing between successive rotational energy level of a diatomic molecule XY. One diatomic molecule is there which is X and Y. Okay, and it's heavier isotopic. Okay, isotopic also it has given. X and Y varies with the rotational quantum number J. Okay, this is one, and another one they are saying that one more is there, both are isotopic, X and Y prime. Okay, X prime and Y prime, or this is X and Y, and they are asking that varies with the rotational quantum number J and spacing between successive rotational levels of diatomic. Okay, so this graph they are asking. Okay, just I'll put what will be the differences for J. This is the J value in X direction, and this direction they want EJ plus 1 minus EJ. So you remember this one, right? EJ plus 1 minus EJ, that is nothing but your 2B value, correct? So 2B value for first, if you are calculating for this, it will be 2B, and for this it will be 2B prime. And now you know that 2B, what is the relation between this 2B and 2B prime? So 2B value will be more than 2B prime. And now how this is grow, we already seen that as we see this 2B value differences 0, and then 2B, then 4B, then 6B, then 8B. So what will be the prime value? Here it will be 2B prime, here it will be 4B prime, here it will be 6B prime, and here it will be 8B prime. So how the graph should be like, suppose for 2B we are calculating, so 2B value will be more, it will go from here, and for 2B prime, where we will get the value? Likewise, okay, the value is decreasing. As we go up, value is decreasing. So this is not parallel, because it is not like that parallel, because the successive energy level, if we are increasing, this difference is getting increased. Okay, it is not like the difference is constant. If this difference is constant, then you will get this graph, parallel graph. Okay, but this one is like one will be in down, one will be in upper side, correct? So which graph will be your correct answer here? So option A won't be, because from 0 it won't start. Okay, and then because difference they have asked, so difference means it won't start with 0, because difference is never it will be 0, because initial will be 2b. Okay, if you are just taking difference of those two, it will be 2b, correct? So option C is parallel, so it won't be possible. Then option D, yes, option D is your correct option. Okay, because they says that this is for xy and this one is for x prime y prime. Okay, so likewise you have to solve the questions, correct? This just now we have solved, right, in previous slide. So the next question we'll see from in 2021, the question number 55. Okay, question number 55. Just we'll rub it. So 2021 question number 55, numerical aptitude type question. Okay, you can see the question in down. The separation of energy levels in the rotational spectrum of carbon monoxide is, see that the line you just read out, the separation of energy level in the rotational spectrum of carbon monoxide is 3.8626. It means they says that 2b value is 3.8626 per centimeter. Okay, per centimeter. So 2b value they are saying. So directly you have to calculate for b, right? And then the bond length. Okay, now they are saying assume it doesn't change during the rotation. Okay, so it is fixed, they are saying. The bond length of carbon monoxide in angstrom. Okay, so bond length they want, means R value they want in angstrom. Okay, this R value they want. Okay, so B value they have given. So for B, how much it will come? 3.8626 divided by 2. How much it will be? 1.9 and then it will be 313. Okay, this will be your value for B. And now we know the formula of B. B is H bate 8 pi square. I just will open it because we need R square, right? Mu R square and then C, correct? So we in that question it has given the values for H. Okay, H we have to put. They have given the value of Na. Okay, now they have given the value of carbon and oxygen in gram per mole, right? So that you have to change it to atomic level. Okay, how much the atomic weight of oxygen and how much the atomic weight of carbon, that you have to change it and then you have to solve it, correct? So first what we will do it, we'll just do like atomic mass will calculate here itself. So atomic mass of carbon, it will be like 12 gram per mole is there. So 12 divided by 6.06 into 10 to the power 23, correct? So how much it is coming? I have already calculated and I kept. It should be 1.99 into 10 to the power minus 23 gram. Okay, minus 23 gram per atom. It means it will be 1.99 into 10 to the power minus 26 kg per atom, correct? Likewise, for oxygen we have to calculate how much it will come. 16 divided by 6.06 into 10 to the power 23. So how much it will come? It will be your 2.66. Okay, 2.66 into 10 to the power minus 23 gram per atom. That will be equal to 2.66 into 10 to the power minus 26 kg per atom, correct? Now just we have to find out this reduced mass. Okay, I'll just rub this formula for time being and then again I will come back to that formula. Just we'll find out the reduced mass. What will be the reduced mass? It will be M1 into M2. So carbon into oxygen. So it will be 1.99 into 2.66 divided by your M1 plus M2. So it will be 1.99 plus 2.66. And now down it will be commonly we will take it 10 to the power 26 minus 26, and top it will be 10 to the power minus 26 into 10 to the power minus 26, because it is multiplying, right? But down it is just adding up. So if it is adding up, it will get cancel out one value with the 10 to the power minus 26 in upper side. Okay, so how much it is coming? This multiplication also I have done. How much it is? These two we will multiply it. It will be 5.29 into 10 to the power minus 26 divided by this, add up how much it is coming? 4.65. okay, 4.65. Now the final value for these two, how much it is coming? If I will divide, it will be 1.138 into 10 to the power minus 26 kg. This is the reduced mass. So we got the reduced mass, remaining everything is given in that formula. We'll see. Okay, so we'll just calculate it. B value is, B is h bate 8 pi square mu r square and then C. So we know that B value we have, we'll just do cross multiply. What will be the value for this r square? We'll take it this side. R square will be h bate 8 pi square mu C into B. Okay, so just put the value for h. H is 6 point, they have given in the question, you can see in the screen, 6.626 into 10 to the power minus 34 divided by 8 into pi is 3.14 square. Reduced mass value we have already 1.3138 into 10 to the power minus 26 into C value will be 3 into 10 to the power 8 meter per second. And what is the B value? B is 1.9313. okay, just you have to do the calculation, that's all. Okay, so in examination also you have to be concentrate while solving this type of question. Okay, either you will get the correct answer or you will not get the answer, correct? So now we'll just solve this mathematical term, and for solving this mathematical term you will have the calculator, right? Scientific, that the calculator, onboard calculator, it will be there. If you want to do the practice for onboard calculator, you can download GChem classes, and there itself you can, the practice problem, right? That problem you can practice it and you can solve it before your examination, correct? Now we'll solve this one. Top it will be 6.626 into, just we will cancel it out, 8 and 26. So 26 minus 8, how much it will be? It will be 18, right? So down it will be minus 18. Okay, if you are cancelling out, it will be minus 18. If minus 18 and 34, if you are calculating, cancel it down. If minus 34 and 18, if you are cancelling out, it will be 34 minus 18. How much it is coming? Because this minus will go top, right? So it will be plus 18. So plus 18 and minus 34. How much it is coming? 4, 8. It will be 6, and here it will be 2, 1. It will be 16. Correct? So 16, 10 to the power minus 16 divided by, here the value will be, this value also I have solved. How much it is coming down? Already I have solved. Value will be 520.07. okay, 520.07. okay, and then how much it is coming? If you are dividing this with this, how much it is coming? It will become 6.62 divided by 520.07. So this will be your 0.01272 into 10 to the power, how much? Minus 16, correct? So now this minus 16, I'll just go like 1, 2, because I need 1.271. okay. So 1.272 into 10 to the power. So 2 places I am moving right side. So it will become minus 18, correct? Now just will, now this one is r square value, right? So for r, how much it will be? 1.272 into 10 to the power minus 18. Simply for 1.272, how much it is coming? 1.272, it will become 1.127 into now 10 to the power minus 9, it will become 10 to the power minus 9, right? But it should be 10 to the power not 9, it should be 10 to the power minus 10, then only we can convert it to the angstrom. Where it has problem, I think somewhere we missed some value for the power. Okay, the same calculation you have to do it, but the value we got it right, 1.127, and in questions they are asking you should get it rounded up to 2 decimal places. If you are getting for 2 decimal places, it will be 1.13. okay, 1.13 value you are getting. So this 10 to the power minus 9, it is coming nanometer, but your value should be in angstrom, right? Your value should be in angstrom, but value we are getting somewhere some problem is there. Okay, 1.9313, this is in per centimeter, right? B value were in per centimeter, we have to convert it to the per meter, right? So 10 to the power minus 2 we had to put here, right? 10 to the power minus 2. So maybe this value we have missed, 10 to the power minus 2, if you're this under root, if you are putting 10 to the power minus 1, so we can add it up here, right? So 10 to the power 10 we can say it. So if 10 to the power 10, then it will become in angstrom, correct? So we got the answer. Again, once more we'll do the review of this calculation. Okay, you also do it and see where the problem, okay, why we are getting 10 to the power minus 9. Okay, so next question we will take it. Number 13, they have asked degree of freedom. Let's see how we will calculate the degree of freedom. Okay, so you see this degree of freedom calculation. After that, any molecule, for any molecule you can easily calculate. Okay, so question number 13 from the year 2019, right? You see the question, the total number of degree of freedom of an HBr molecule that is constrained to translate along a straight line. Okay, they have twisted, but doesn't have any constraints for its rotational and vibrational. Okay, so we'll see the concept first and then we'll solve it. Okay, so what is degree of freedom for a particular molecule? Okay, there will be two types. One will be translational, okay, where the center of mass will also in motion. Okay, in translational, the center of mass will also in motion, and which direction? It can be x direction, it can be y direction, or it can be in z direction. So total 3 direction of motion will have this translational one. Okay, so three translational energy level we will have. Okay, degree of freedom. Okay, it can move, it can freely move towards the x, it can freely move towards the y, it can freely move towards the z. Okay, so 3 we have. Now the second one is internal energy level. Okay, internal degree of freedom. Degree of freedom. What is this internal degree of freedom? This will be of two types. Where the center of mass won't be in motion. Okay, where the center of mass won't be in motion. Translational, the center of mass will be in motion, but in internal degree of freedom, it won't be in motion. In that, two types will be there. One will be your rotational, and second one will be your vibrational. Okay, now for rotational, again two types will be there. One will be linear, another one is for non-linear. Everything is going to be get clear for you, right? Here there will be two rotational energy level. Okay, two rotational energy level means two rotational degree of freedom. For non-linear, it will have 3 degree of freedom. Okay, 3 rotational degree of freedom for non-linear, and for linear it will be only for 2. Okay, now in the vibrational level, how we are calculating how many vibrational will be left over? So for a particular molecule, okay, if it has n number of particle or n number of atom, suppose it has n number of atoms, what will be the degree of freedom? It will be 3n. Always it will be 3n. Okay, so freedom will be, degree of freedom will be 3n. Now you just see this is the total degree of freedom 3n, correct? Now if you are calculating for particularly how much degree of freedom present in internal degree of freedom, so this internal degree of freedom you can say 3n minus this f equal to 3n minus 3, because you are just subtracting the translational degree of rotation, right? Because you are just finding the internal degree of freedom, so you have to just cancel it out, this 3n minus this 3, this translational degree of freedom you have to minus it, so 3n minus 3. Now for vibrational, if you want for linear molecule, okay, if linear, again you can subdivide for linear and non-linear. Okay, for linear molecule, if you want the degree of freedom, like number of degree of vibrational level freedom, so it will become 3n minus this 3 you do minus and this 2. For linear, 2 minus 3, so 2 minus 2 minus 3, it will become 5, so 3n minus 5. And for non-linear, it will become 3n minus this 3 and this 3 together, it will be 6, so minus 6. Okay, these are the rotational vibrational degree of freedom, correct? Vibrational degree of freedom. So these are the formulas. Okay, translational always it will be 3, and internal degree of freedom it will be always 3n minus 3. And suppose you want particularly for vibrational level, for linear molecule it will be 3n minus 5, for non-linear molecule it will be 3n minus 6, correct? So now we'll just see 1 or 2 examples and then directly we'll go to our problem, correct? So if suppose you are calculating for H2O molecule, okay, just for H2O molecule. H2O we know that it is non-linear, correct? Just write it down, non-linear. Now they are asking number of vibrational degree of freedom, okay? So number of vibrational degree of freedom, how you are calculating? For non-linear, it will be 3n minus 6. And what is the n? Here we have 3 atom, right? So it will be 3 into 3 minus 6. So how much? 9 minus 6, it will become 3. So 3 vibrational degree of freedom it will have. So current question, okay, current question, what they are asking? You see the question, they are asking for the molecule HCl, correct? They are asking for this molecule HBr, sorry, not HCl, they are asking for HBr, and this is diatomic. So what is the value of n? It is 2, correct? Now what they says, they have just made one condition here. The condition is the HBr molecule that is constrained to translate along a straight line but doesn't have any constraints for a rotational and vibrational. So for rotational and vibrational there is no limit. For translational they have made a limit. What is that limit? It can travel only to the straight line, means only one direction it can travel. If you are taking x, so only x coordinate it can travel. If you are taking y, it can travel only y direction. If you are taking z, it can travel only z direction. So directly from translational degree of freedom you are getting 1, because only one direction it is allowing. Now for this is HBr and this is a linear molecule. For linear molecule, rotational how many will be there? We know that rotational degree of freedom will be 2 for linear molecule. Now we have to just find out the vibrational degree of freedom. So vibrational degree of freedom will be your 3n minus how much? For linear molecule it will become 3n minus 5, right? So here 3 into n is 2 minus 5, so it will be 3 into 2 6 minus 5, it will be 1. One vibrational will be there because only one bond is there, so the vibration will be like this. It is like a spring, right? So vibration will be, so only one direction vibration will be there. So 6 minus 5, it is 1. So here it is 1, here it is 2, and here it is 1. So total how much it is coming? Degree of freedom 4, total 4. Okay, if they are not putting this condition that constraint to translate along a straight line, then this will become 3. So 3, 2, 5 and 1, 6. So total degree of freedom will be 6. Okay, but they have limited here. Translation they ask only for one direction. Okay, so now correct option will be 4. So question number 13, the option C will be your correct option. Now any other questions are there from this particular year? Okay, we have, okay, question number 33. So what it says, among the following microwave active molecules, अच्छा, among the following microwave active, इसमें से कौन माइक्रोवेव एक्टिव मॉलिक्यूल है? करेक्ट. सो हमें पता है इनिशियल जब क्लास स्टार्ट किए थे उसी समय बताया था कि माइक्रोवेव एक्टिव मॉलिक्यूल वही है which is having permanent dipole moment. Just see for these molecules which one is having permanent dipole moment, that will be your microwave active. Okay, first molecule is, okay, this is question number 33, correct, from the same year 2019, trans dichloroethane. Okay, so trans dichloroethane, okay, that's why trans dichloroethane. So one chloro is here, one chloro is there, hydrogen is here, hydrogen is here. So see, this one is in this direction, this electronegativity is in this direction, so both are getting cancel out, so dipole moment equal to 0. So option A won't be your answer, and this is MSQ, right? Question number 33 is MSQ. Option B, what we have, 1,2-dinitrobenzene, 1,2-dinitrobenzene. Here it will have dipole moment. Okay, suppose this nitro, if it is in this place, then we can say that this one and this one is getting cancelled out and mu equal to 0. But in this place, mu is not equal to 0. Okay, because see, both are in same side, correct? Now the option number C, what we have, 3-methylphenol. For this phenol kind of thing, wherever you put this methyl, 1, 2, 3, it will be always having dipole moment. Okay, it won't be 0. Okay, because if you are putting here also, because there are two different molecules, so to pulling this one or to giving from the electron density releasing from CS3, both will go one side only, right? So there will be a permanent dipole, correct? So this is also active, this is also active. Option D will see. What is the option D? Para-aminophenol. Okay, para-aminophenol. Okay, you just write the upside or downside, there is no problem. So it is only 1,4 position. Okay, 1, 2, 3, 4, 1,4 position. So now you just see, this is nitrogen and this is oxygen, both having different pooling capacity, like electronegativity difference is there, right? So they having their own pooling capacity, and based on that, this will also not have this will also have dipole moment, permanent dipole moment, and it is not equal to 0. So this will also correct. So option B, C and D will be your correct answer. Okay, so this much from rotational spectra. Tomorrow you will see your vibrational spectra, okay, and then NMR spectra, correct? So I hope you are enjoying, and if you are enjoying, please do like and subscribe and share to your friends. Thank you very much.